Okay, so today I just decided to kind of wing it, and then we're gonna talk about something called self-supervised self-supervised learning. And then um first I'll try to explain it as thorough no, as like organized as possible. So before self what is it called? Self Wait, I just said it. I can't believe I just forgot what I said. Self No, what is it called? Oh my god. Self Self-supervised learning. There were just normal supervised learning. And so normal supervised learning basically requires a lot of data. Uh, normal, how about normal? It requires a lot of data that's marked. So, for example, you can train a model to differentiate between a cat and a dog. What you do is that you label this as a dog and you label this as a cat and then feed it to the computer. And then the computer, through its vast operations, is basically a lot of matrix operations. And then it tells you, okay, it gives you a set of, what do you call this? My English is so bad. It gives you a set of 参数. And then it's basically a giant matrix. So next time when it does when you give it a photo, it can tell you what it thinks this should be based on probability. Okay, so the very basic implementation of this is to tell the dog and the cat. However, since there are some fields that just don't have that much valuable data. It's not like there's some fields like medical fields that there just aren't that much data. Like if you were to spot tumors, there just wouldn't be that much data of where tumors are, or because the only people that can mark them are like expert doctors, and it's not like everybody knows where a tumor is. Like everybody knows to differentiate between a dog and a cat, and so then we need something called self-supervised learning. What it does is that instead of learning everything from the beginning, it tells you, okay, it first gives you like a bunch of, for example, it gives it a bunch of photos. And so, for example, this is a full photo, and then it gives it like maybe a half of a photo. And then it tells the computer to predict the next photo and then calculate the difference between the real photo and the one it predicted. And so by doing so, without a lot of data, without a lot of photos or data, you would be able to achieve sort of like the same effect. And so this doesn't really rely that much on data, but after it gets a basic understanding of everything, you still need to kind of fine tune the entire model and give it some actual like marked data of like where a tumor is, whether this is going to be a tumor or like a pneumonia. What is it called? 肺炎. Pneumonia, I think so. You're still gonna have to give it data, and so I guess that's my kind of thoughts on self-supervised learning. And then so I think a self-supervised learning provides you with a foundation model, and then it gives you sort of like a fine-tuning, and then it does everything. So this doesn't really rely that much on that much mark data, and so sort of like that. And yeah, and with this, the kind of edge over normal machine learning is that it cuts off a lot of the unnecessary steps. For example, normal supervised learning, you would be giving it a lot of photos, and it can be learning from, for example, you give it like a photo of like a cat. It can be learning, okay, maybe it has eyes, then it's a cat, or maybe it has a certain stripe, then it's a cat. And so it can be learning, like it can be grabbing features from a lot of unwanted places. Well, with self-supervised learning, you give it a bunch of data, and then you tell them, okay, so all of this is a cat. and now you're gonna say, and after it knows a cat and a dog, you're gonna have to fine tune it, like what type of cat this is, and so it's just more efficient. However, it's also more reusable. But like the kind of downside about self-supervised learning is that, first of all, it needs a bunch of starting data to begin with, because you want it to have the basic idea in mind, like so you want to know like this is a cat and that's a dog, and then you can kind of fine tune the entire model. And so yeah, there are pros and cons of this, and then a lot of the AI we see today is based on self-supervised learning. For example, I believe Sora and then GPT, which is basically Sora, are all based on self-supervised learning. And self-supervised learning is just a pretty good way. And so you're also going to come across the question of, okay, so self-supervised learning requires, for example, a bunch of basic information, like a bunch of basic data, and then it requires some very fine, like high-level data. And so the natural question arises, like, how do you know if I'm just missing the original data, or I'm missing, for example, the fine-tuning data? So there are lots of ways. For example, it's a neural network, so you kind of freeze. You only move the last layer, and if it turns out good, then you basically have the first. So you basically have the pre-training kind of phase done, and it's just fine-tuning that's left to do. But if it's basically guessing, then it means that the pre-training, you just haven't done anything. So you need some more pre-training. And yeah. And that's basically self-supervised learning. And then that's basically self-supervised learning. And then there's also something else. And so I can tell you why like photos are necessary for like deep learning. So for example, deep learning is that it has a bunch of information, and it's just naturally good for the computer, because you give it a bunch of information, it's definitely going to have a good outcome. And so the computer is also really good at finding like invisible traits of like photos. For example, there just might be invisible like patterns that you just might not see with a human eye. And then especially in a medical field, it can actually capture more details, because a human will get tired eventually, and a computer does not get tired. You feed it its information and it gives you the outcome. And it's also good at just grabbing these features, and that's just why it's just good. Photos are just good for deep learning. And then there's also classification, segregation, and then detection. There's also a lot of that stuff. And so everything is just like that. Yeah.